Hello guys, I hope this meets you well. How are you doing? So in today's lecture, we'll be talking about integer modifier. In our last lecture, we actually treated integer. So what we all talk about is just very simple stuff, but I make it long so you guys can understand. So what we actually talk about is that integer stores decimal number. So it holds decimal number and it stores or it holds 4 bytes in memory. So that is integer. That is the data type. That is how it works for integer in C++ program language. So the data type, it is used to store decimal number and it also holds 4 bytes or more. I was specific like 4 bytes or more. So it does not really have limits to what it can store in the memory, because we're going to be talking about that in this lecture, how we can extend or how we can modify, and that is why it is integer modifier. So that is why we are trying to bring it more closer to what we can understand. So integer modifier, so that's why its topic is like that. So how we can actually modify its memory, or how we can either use excess of the memory or use little quantity of it. So now we have integer modifier, and it's the description written here is just like the episode of C++ lab. We dive into integer modifier like sign, unsigned, shorts, like these ones here. Sorry. So sign, unsigned, short, and long. So this specifically, we'll be talking about this, and these are the modifier of C++. Of integer. And I'm very sorry, in my last lecture I mentioned a lot of integer instead of saying int. I am so sorry. I am very used to integer instead of int. So int actually, but now the topic is integer modifier. So in this lecture, we'll be learning how we can actually modify the integer, or how we can optimize it, so we can have effective memory usage and performance. So in my next slide there, I have integer, and I said stores positive and negative number. In my last lecture, I actually say we stores both negative and positive. We all understand that we can actually store positive and negative number using int. That's integer. So when we use int, we can store both negative and positive number. So that is what you should understand, which is decimal number, which is decimal. So in my next slide here, I have what we call sign, and this is my data type here. So let me just give it color. So yeah, this is my data type. This data type, which is sign int. So what sign int does, it give me access to use both positive and negative number, just like I'm using int. So they are just the same, and they have the same size memory. They have 4 bytes in memory. So this is the variable I explained, that integer allows the variable to store a specific data type. Data type allows a variable to store a specific value. Don't let me confuse you guys. So now this integer stores, or it allows decimal, and I can't store character here, like stuff like this. I can't store it there. I can only store decimal number, which starts from negative to positive. So in the next one here, we have sign int, and it stores -50, which is the negative number. So I am actually saying the same thing here. I'm referring to both instruction here. So we are still talking about the same thing. Store 4 bytes in memory, and holds the value of 10 and holds the value of -50. Just that the value of this variable will be different, but what it stores, or what this memory holds, is just 4 bytes. They are holding the same memory size. So I hope you guys understand that. So it stores both negative and positive. So you can actually use it to store both negative and positive number using sign int. So now in next, if you go down a little bit, and I'm sorry for using the both of them in just one slide, but I'm sorry about that. That's not professional. I mean professional. But I know. I'm sorry about that. So in this particular part here or slide here, I have sign int and I have this particular gibberish thing you don't understand. Okay, fine. I will explain there. So what this is actually telling us that we can actually store from both negative number to positive number, which we actually know or understand from our last lecture today. So this is the value of the bytes we have here. So this minus n represents the value of the bytes. So now we can actually store both negative and positive number using sign int. And when we go to the next one here, we said unsigned. This is new to us. We actually talk about sign that we can actually store negative and positive. But when we get to unsigned int, it's different. Yeah, I know that. So what unsigned int actually does is that it stores only positive number. Try to understand. It stores only positive number. Like you can't have access to negative number like minus, like you do have it here. You can't have negative number. So it stores only negative, positive number, but increases the value for us. I'll explain what that means. You know, int stores 4 bytes in memory, and they both store 4 bytes in memory, but how they handle their data is different. How sign int handle data is different from how unsigned int handle its data, because the value of this one is starting from -2 and the value of this is not starting from -2 because it is starting from the positive number. So it have access to more value positively, I mean, than sign int, which has access from the negative part to the positive part. For you guys to understand that, we'll go to the next slide again. So let's zoom out and see what is there. So in here we have types of modifier and bytes in memory, and we have size. Very good. So this sign here actually stores, or let's say sign int, like we explained here. I said it stores what? It stores only positive number, and it consumes or it uses excess of data positively, but does not have access to negative number. But this sign int use its value from the negative to positive, but we'll try to understand that in this place. So here we have bytes in memory, we have 4 bytes, and in the size is actually from 4. How many zeros do we have? Sorry, how many numbers we have at the back? This 6, 9. That's 4 billion. We actually have access to 4 billions of size of memory in unsigned, which actually store from positive, which is 0, to this particular number, which is 4 bytes in the memory. So this is what 4 bytes means when we are talking about 4 bytes in memory. So in real life number, this is what actually it can contain. It can hold more than this particular number we have here. This 4 byte and this 4 billion to, you know, I don't know, I can just start pronouncing that. But now just try to understand that it can't go beyond this one there, which is positive, starting from 0 to this number we have here. So now that is what unsigned int does. It stores positive number, and it does 4 bytes in memory. And I say that this is what 4 bytes in memory means. I'm sorry for repeating myself again. So now we talk about sign. It stores 4 bytes as well, and its value starts from -2 billion, and it stops at, you know. Now if you should remember, I said sign int actually holds more. Sign in actually holds from negative value to positive value. So now we have -2 billion and this plus this. So that is how sign in actually works. It instead of starting from 0, it doesn't start from 0. So we can actually store this particular negative number in the memory, but we can't use 4 billion in this in sign in, because it only starts from minus 2 billion and stops at 2 billion. You understand what that means? So it divides the memory, it divides the value, like it cuts it into two and use half for positive and half for negative. But this unsigned int consumes everything for positive only. So I hope you guys understand what that means. So let's just don't waste time and go to the next class, and that's it for this one. And let's just before we go there, let's try and check the memory. So now I actually explained that it stores what? It stores 4 bytes. So this is what you need to have 4 bytes in memory. If you should have this in count, it actually contains, this particular lines contain 4 bytes actually. So this is what 4 bytes actually means. So they both hold the same thing, both signed and unsigned. They both hold the same thing, but they deal with their data differently. Unsigned stores only positive, and unsigned, let's say this is half of the value. So unsigned actually did what? Consume the whole part for positive number, and when it comes to sign, it used half of it for positive and half of it for negative. So I hope you guys understand what that means. So that is how we can actually modify our value using signed and unsigned. And if we go to the next slide, there we have little details on how we can, more details, I mean, not even little, how we can actually modify our memory. So in memory, where we have, or let's say in our code, let's say this is an example of our code, we have short int, and we have our variable where we store our data, and we have the data which is starting from minus this. So now short also is a data type that actually modify integer, but it holds only 2 bytes in memory. You know, instead of having 4 bytes we have here, instead of consuming 4 bytes we have here 4 bytes that we have here, it only takes half of it, only half, and use the half. So it doesn't go, or it doesn't, let's say, it uses the half of the memory to declare both negative and positive. No, this is a 4 bytes in memory. This is 4 bytes. And when we use integer, so when we use short, this short, and short only consume half of this one here, half of this. Let's say this is the half, or let's say this is the half. And in this half also, it split it to 2 and use negative and positive. So that is how it works. That is how short works. So it stores 2 bytes in memory, which doesn't consume the whole 4 bytes here. It only stores only 4 bytes in the memory. And so now that is how one way I said we are trying to optimize our memory or our programs there. Instead of using excess of data, no, you know, example, if you just need just little amount of data, you can just use short. And when you use short, you should know that short actually stores negative and positive number, and it holds little amount of memory, which is 2 bytes. Doesn't hold a lot of data, short data like that in memory. It only holds 2 bytes. And when we go to int short, so it also stores both negative and positive. So we are actually literally saying the same thing here, using these two things, and just to specify it. And here we have signed, short, int. So we should know that sign is stores from negative to positive, and it has 2 bytes in memory. So all these things we have here, they all have 2 bytes in memory. As long as they are short, it stores 2 bytes in memory. And we have sign here. Sign actually stores positive only, so it also holds 2 bytes in memory. So I hope you guys understand what that means. So and when we get to the next one here, we have int. That's the normal int we actually know, or we have been using from the beginning of the lecture. So int actually stores 4 bytes. Actually, I didn't even specify that. It actually stores 4 bytes. sorry, it actually store 4 bytes in memory. So starting from the negative to positive, that's how specifically when you use int, that is how it works in memory. It stores from negative and positive. But when you are trying to modify it to specify the value you are using, you can just use signed int. It makes you look more, more professional, more acknowledge about what you are doing. When you just use only int, it means that you are just maybe normal coder, just normal stuff. You're just doing normal stuff. And when you have this idea that sign int, you're going to have this idea that yes, okay, sign int is just modify my integer. It's an advanced way of dealing with your, or modifying your, or dealing with integer actually, or an advanced way of, an advanced method of actually using integer by using sign int and stuff like that. So sign int usually store negative and store have 4 bytes memory. Also the same thing here. So specifically every value you find here store 4 bytes memory, except, no, not even except, they all store 4, but this already store negative and positive, I mean. So try and understand what that positive and negative. So we're going to use that in the code, in the Visual Studio. So when we go to this long variable, and what's long and short again, so it's still convincing, stuff like that. Okay, this is very easy to understand. Just try and listen carefully. Long also is just a data, is a data type that modify integer. They are identifier under integer, so they modify integer also. So long actually consumes 4 bytes or 8 memory. So it's consumed 4 bytes memory. It stores positive and negative as well. So same thing happens to sign, and the same thing, just like we are referring to short we have here. So it's just the same thing. So let's go to the next one, and sorry about that. The next one actually talks about long, and long is very is like the highest maximum, or let's say the maximum number you can use, or the maximum memory, I mean, you can use declaring of integer, because actually it stores 8, not even 4 bytes. It stores 8 bytes in memory. It stores 8 in memory. So whenever you use long, it literally stores 8 bytes in memory. But that's why I said we can actually modify our integer. So modifying your integer gives you the access to use, either use minimum or maximum or just normal. Your normal memory size, I mean. So here we actually have maximum memory size, which is 8 bytes in memory. So we have long, and I declare the variable, which I put 31 in front, and I declare the same thing as well. And all these things you see here, they all stores as well have 8 bytes in memory, because they have, like, I use excess of integer, and I said, okay, I want to use 8 bytes in memory, so I have the access to use 8 bytes in memory, having control over my address or my programs. Then by using long, and I can have access to 8 bytes, not 4 bytes anymore. So I hope you know how 4 bytes is. This is what I mean by 4 bytes. This is what I mean by 4 bytes. In value, this is what I mean by 4 bytes. So if you should add the 4 plus 4 again, it's going to be 8. So now you're going to add this number together. So you're going to see how big the size is going to be. So that's how maximum the size is going to be. So that's how large the value that you can store in long is going to be for you. So I think that's what you guys should understand right now. And let's go to Visual Studio Code and work, and stop talking. Let's just do something good. Okay, fine. sorry. So now you just cd and paste the value and code. I don't need you, Antimo, minimize, I mean. So now we're gonna use those value we have here. Let me just go to the code and copy those data. You need to copy those data. Actually, guys, I've tried and I've put this code down. You can just put yours down too. So first thing, you're gonna comment this part here. So you can actually hold your control and press your slash, your right slash, this particular slash here that's on your keyboard here. Just press your control and press it together. It's gonna, once you unlight it, it will comment everything. So now let's try and work on this particularly. So let's try and work on this first one we have here, and let's deal with something about that. And yeah, I hope you can see this thing, or let me zoom it more. Doesn't look good, but I think it's okay like this. So fine, I have my library declared, fine, and entrance code main, and let's go and work on something. So shorts, so we can actually store, or let's try and, what should we do? Print. First thing I'm going to do is that I'm going to check the size of shorts in memory. Size of shorts. So I'm going to check the size of everything in memory. So I'm going to take the size in memory, and I'm going to store, instead of storing positive in this particular unsigned, instead of storing positive number only, I'm going to store negative number. So you see how our data is being treated, or how our value is being treated in our, or how our compiler treat our values. So now I'm going to do what SB in, sorry for saying that. So okay, good. So now I'm gonna use everything in facts. So sorry, I think there's error here. It's supposed to be short, int, not int. It's supposed to be like this. Oh my goodness, I'm confused. Like, it's supposed to be short int, not int short, or whatever it should be. Oh, not right. It's supposed to be short int. Short int, yeah, short int. So now short. This is gonna be a lot of typing, and come on. So sign in, signed, or let's just use the variable direct. You can use the variable direct like we did that in the last lecture. That, but even though we check the size of our variable using the both data type, it's gonna give us the same thing. And oh my god, I see there's error here actually. I use short int, short variable here. I use short variable here. I am declaring the variable again. That's one of the bad, or that's one of the bad thing, or let's say bad method, or that's one of the reasons you should not copy code and stuff like that. What I have here is bad. What I have here is actually bad. Let's just make it short int variable. It's gonna be a very long one. So I'm gonna have short int, short variable, short int variable. So I'm gonna have a signed so signed short variable. So yeah, I'm gonna have unsigned short variable. So this will be very okay for me. So now instead I'm gonna store the variable directly instead of using the data type. I can either use the data type or store the data himself. So let me just store the data. Next one should be sign short int. So what's that? Sign short int. Sign short int variable, not you. So but we're gonna store the value and the size in the front, so we can, you know, can use it. So the value is gonna be a very long one. Sign short variable. Or to make it more look organized, let's just do something like this. Please, I don't have time for you now. Okay. So now I am actually storing the value here, and I am storing the, here I store the value, signed int short, or signed short int variable. I didn't indicate variable, but don't worry. So signed short int, which is this one here. So yeah, I actually put the value. What's the value in the front? The value is minus 347. So but yeah, it's gonna be in the size of it. So the size is gonna be, let's check the size. So in the front, let's just put bytes in the front. So it will just look ordinarily. So that's good for that. And in the next one here we have this one, which is signed short. So let's try and do the same thing we have here. So signed short, we're going to print the value of signed short. Signed short is not going to be int anymore. So signed short, so we're going to do signed short. So yeah, we're gonna do the same thing as well, the same thing we did in this following one we have down here. So we're gonna do the value short int I still be short in var. So, and we're gonna have shorts. Let's change the data type. Let's change data type to the variable name. Or how should we do it? Should we leave it down, or anyone we feel like you can just use? Or let me just use the. Let me leave the data type alone. Let me leave the data type alone. I'll just print the value here, print the value, and here, and we'll be using the data type here. So it's not bad if you use the data type. It's not bad anyway. You can just use anyhow you feel like. So what data type I have here? That will be signed int. It's not going to be variable anymore. So okay, in the next, this I think that's all. That's all. It should remain just the value. I didn't specify. And this side here is gonna be. I didn't specify the bytes too, or it don't look okay if we print them, or we have them on the terminal. It don't looks okay. So now we have what we have here is size of. Okay, no, it's not gonna be size of here. Here is gonna be size of, and here is gonna be data. The value itself. So what's the value? Value is short variable. And we're gonna have it here this way, having the data, the size of the data in the memory. So I think okay, just little. So we won't do everything at once. We just do it little by little, so it won't look much or looks so junks on the. So we treat them one by one. So now we are actually working with shorts. Shorts. So we're actually working with shorts here, and we have the value here printed here. So here we have shorts, ordinary shorts, and we have it printed here, which is going to give us 2 bytes in memory, and we have the variable size which we have here, the value we have here, and we have that for that. The next one we have, it should remain one, it should remain unsigned. I haven't used unsigned. So unsigned shorts. So what's unsigned short? Unsigned shorts. So that's it. I think that's it for that. And let's have it printed in the memory. Let's have them printed in the memory. So now you can just run your code. So, and I think that's it for here. So here is going to give us the value of our data in the front. Every value we had in the front is going to give it to us exactly what we had in the front there. It's going to give it to us there. Even though the value looks all familiar. And let's try and talk about this in int. That's why I don't like it. It's gonna slow and it's gonna be running so slow. Okay, let's try and work with this. Let me see if we should have time variable. Okay, good, fine, and let's try and check what we have here. Okay, time is going. Okay, fine, good. So here we have so simple, and as we have say, or as we have mentioned, we have it printed on the screen here. We have short int and it stores minus negative number, I guess, or I mean, and it stores 4 bytes in memory. Okay, I have same thing as unsigned. I have it also here, and it stores positive and it has 4 bytes in memory. So now let's do something crazy. Now I'm gonna do what? I'm gonna store positive negative number here, and let's see how it's gonna work. Let's say minus 10. So now let's run it again. So we are storing negative number in unsigned short, which doesn't really make, which is not really making sense. Like, which is not really making sense. I am trying to do something that is something that doesn't exist, something really very crazy. So if I should run the code here, it should, you know, do something crazy as well, the way I'm trying to do something crazy. Yeah, compiler is complaining already. So the compiler is saying something that we have int and short int, so we are trying to store negative number in our unsigned short, which means we actually can't store negative number. So that is what it is. It pronounced you error. It gave me error because I'm trying to do something really crazy. So if I should just, the only word I can just do is to either use short, and to use less of my memory, short, it contains 2 bytes. So in case you are trying to use it for your pro code, or for your software or whatever you are doing, instead of using excess of memory, using int, and you can just use short. And short usually use minimum of the memory, and instead then you can just do short and use short. And if it is a positive or negative number, you can just use unsigned short or signed short, anyone you prefer to use. So it's gonna be cool for you guys. So I hope you really like what you see. So now let's go to the next one, and let's comment this out. But I wish I could use this part. I don't want to type very much, so I wish I could use this much here. And I'm going to highlight the particular place again and comment them out. Comments. So I'm going to the next one, which is this. I want comment where. Do the same thing. Hold your control and press slash there. It will comment it for you. So now, okay. I should not have uncomment this. Unsigned int. What happened to you? Okay, did I reuse you? I think I reused. I didn't really use you. Or I don't know where the blunder is from. Or is my spelling not correct? Unsigned. Well, let's just work. This is just unsigned int, and I don't know why it's giving me. Okay, so I have, okay, sorry, I don't have my, that's about, I don't have my semicolon here. So that's something crazy about code. It's just single mistake, single error can give you something really blunder. So see what is here, what is causing my error. I was like, this thing is correct, and what's going on, and I don't know that I actually missed semicolon here. So sometimes little stuff can cause error, can even stop your code from working. No matter how you put energy in it, just one thing like this can fuck everything up. So now let's just do something about that now. So now I actually copied the code I have there in the last place, and let's try and work on it. I don't want to use much, and I know it's going to be a little bit stressful because those variable does not exist anymore. So I'm going to change this variable one by one and check the value and check the size. Check the value, check the size. It's going to be int again. It's going to be what? Int, and here it's going to be size of sign int, and here is going to be sign int variable. Instead of shorts, it's going to be sign int variable, and here is going to be signed variable. Sign variable, sorry, sign actually works as, I think we used that sign. No, we didn't. Actually, we didn't, because sign actually contains 4 bytes memory. So sign actually contains 4 bytes memory also. So let's try and do something here also. Sign int. So actually, if you change, I'm gonna change a lot of stuff here. It's not gonna be short again. Size of int. And I even make error there. Does not make sense. Size of int. So let me just print the variable out instead. Int. I make error there. Even up there I make error. It should not be like this. It should be the specific value there. So yeah, we're gonna have we're gonna have this as well. This is going fine. Okay, so what's this? It's gonna be only sign, and this is gonna be unsigned, but I won't use that since I actually have 4 data type here, and I can clear that away. So I'll just use unsigned int here. Unsigned int instead of short. I'm gonna clear this short away. So I'm gonna be unsigned int. Okay. So I think our code is set here. So now it's gonna have 4 bytes memory. We have int, we have variable of int variable, and we have int here, and we have everything is being stated well, I guess. Okay, everything is fine, and let's try and run the code. Let's see our results. So, and before this ends, because taking time, I want to explain something to you. I want to show you something. So in our PowerPoint here, I actually didn't specify something. I want to give you to know that modifier only applies to integer, not all types. This is which you can actually store decimally. So this modifier that we are doing, this unsigned int, it is only used for integer only. So when we get to data types of double, float, all those data types does not have anything like signed double or unsigned double. It doesn't go. It only is integer that can be modified in that way. So try and note that it's integer that has the access to modify, to be modified, not other data types. So I just wanted you guys to notice this before this code runs. Thank you very much. So it has been built successfully, and let's just try and check what is in our code. Okay, very good. I have my data stores as well. So now you see signed, integer, and for having minus, having the access to print negative number without giving error. Also that's negative number without giving error, and it contains 4 bytes in memory. So that is how much we can actually store in memory. And when we want to check it out, so we can actually see it from this particular part there. Sorry, this is the large amount that we can actually store in unsigned int, including int also, but we cannot store this amount in signed int because it's only start from negative number and stops at, starting from minus 2 billion and stops at 2 billion. Does not have access to print 4 billions. So just try and check what that means, what this byte actually means. So now I hope you understand what this actually works. So now our code works fine without pronouncing or giving error. So let's comment this out. I'm going to copy this one as well, and I'm going to comment this out. So there is also, I'm going to highlight this part here and do something like this, and here I'm going to say no. So now there's error here again. I didn't add something here. So yes, there are error here because the variable does not exist again. I have actually commented them out, so I want to use them again in this one. So here is going to be long, and or let's just, I want to ignore this one. You guys should do it yourself. It's the same thing. Do it yourself. Let me just go to 8 bytes here. So to use less of our times, I don't want to consume all the whole time finish, and just because I'm explaining integer modifier, then what? So now I won't consume all your data. Just do that yourself. I don't want to exhaust your time, and I'm gonna use something here, and let's check the byte stuff. So let's check the value, and let's check. That will be long. Let's just copy. Let me just copy. I want to make this new really fast because I think I've been spending much time making just simple videos and making it very long. So here it's gonna be long integer. So it's gonna be 8 bytes in memory. The out takes 8 bytes in memory. Sorry, I'm actually printing the variable. Please change to yeah, I'm gonna have signed long variable. Oh yeah, long int variable. Same thing, I should just copy this one here. So just, you can fast forward the video if you feel like. I will actually end this up, and at the I mean just try and actually adapt, or you can fast forward it if you just feel like. And though we are still coming out, still rounding up on the same place. Sign long, and long, or what's the signed long. Yep, that is what is there. So the last one we're gonna have unsigned. So I don't want to use on that unsigned again, store negative number there. Just know that you can't store negative number in I mean in unsigned. So it won't allow you to store negative number because it starts from positive number and this is very long, then very long. Just like long is long. Okay, signed. Okay, I think I am initially done. Okay, I think we are good. Fine. So you do this yourself just to reduce the amount of time you are spending trying to understand integer modifier. So now let's just run the code and look at something. So as this work, okay, I'm gonna give you a bonus strip. So bonus. Don't worry, I'll give you the bonus in a way that once I'm done with this particular one, I'll tell you something again. Tell you guys something really okay. Good. You see it as stores of 8 bytes, and this is actually what our aim of, or at least our specific aim actually. So we have our data printed, our data is being printed, the data we stored in the front are being printed 31 or 30. Yeah, that is what we stored here, and they are fine. And that consumes of 8 bytes. So that's, and you know what 8 bytes means, you know the amount it can consume now, since you know, or you have seen the maximum number, you have seen it from the previous slide we actually viewed. So now let me show you one thing again. So there's all just reduce stuff, not much. Size C. This is it. Size C actually allows us to store exactly the size of long int, but it's very simple way of using it, and it's not really common like that. People don't really use it, but actually, and it's a modern features. So it's not an old method of it's a modern features of C++. So signed int actually stores exactly the amount of memory long signed store, instead of typing all this old stuff. Sorry, this, instead of typing all these stuff here, you can actually have them in this size int. So let's store something here. So let's say we have max, and max has what, 100. So max can actually store the value of 100. Max can actually store the value of 100. Sorry. And size of max is 8 bytes. So we're gonna do size of. You can either use size C, or let's use, you can either use size C or max, anyone you feel like. And you're gonna see that this also stored 8 bytes in memory. So good, let's just run this code and let's see what is gonna happen. I don't even need to comment anything, and let's just do something, since I divide it with 9 here, so I don't need to comment anything out. So the amount of this particular size here, we have signed long int, it stores exactly the same thing of what we actually have here. Okay, good, and let's try and run this, and let's try and check the code. So good, this is it. You see, marks have the size of what, 100, the value is stored there 100, and the marks, the size of marks here we see is 8 bytes, just as well, but we didn't put the things, the string, or we actually put there, we didn't put it there too, but just so that it stores also 4 bytes, 8 bytes in memory. So that's how, that is what size int also works. So that's the maximum size of integer. So you can actually use size c, it stores integer, the max size of integer. So let's store actually negative, and let's see what's going to happen. Let's store negative and let's see what's going to happen. You know, we have signed long, so we have signed long int, and we have unsigned. So now we have the knowledge that signed size c actually stores only positive number, which is unsigned. So definitely it is not what we see, what we expected here. Okay, now maybe you are expecting it should give you size long int. No, this is what we actually means here. So it started from the positive number, and it started from 0 to positive number, so we can actually store negative number in size c. It takes only positive decimal number. So I hope you understand that. So I think that's all for today's lecture, and I hope you guys enjoy and understand what integer modifier is. So it makes us to optimize our memory, doesn't give us or won't allow us, or it helps us in managing our data or managing our memory. So that's it. Thank you very much. Bye.